Imagine this, a human body, untouched, lying deep within a cave for 10,000 years. What would you find if you could peer into this ancient tomb? When life leaves a body, an incredible and inevitable process begins: decomposition. It's not instant disappearance, but a complex series of biological and chemical reactions, each stage playing its part. First, there's autolysis, the self-digestion of cells by their own enzymes, breaking down tissues from the inside. Soon, an army of microorganisms joins in, mainly bacteria living both inside us and in the environment. They start putrefaction, actively breaking down organic compounds. The speed of these changes varies greatly, depending on many factors. Temperature is key. The warmer it is, the faster the reactions. Oxygen access, humidity, scavenger insects all influence the rate of decay. In the normal world, a body quickly returns to the cycle of nature. But what if these factors were radically different? What if the body were in a place where time seems to slow down and conditions are stable and unusual? A deep cave can be just such a unique time capsule, rewriting the usual decay scenario. What if we told you a cave isn't just a dark shelter, but an ideal time laboratory that can slow down the inevitable? Do you know what unique factors make it such a special crypt? A cave isn't just a dark hole, it's a unique natural lab with amazing stability. Here, the temperature is usually low, but above freezing, which dramatically slows down the biochemical processes of decay. It's like a natural refrigerator, where time moves slower for organic matter. Humidity is another key factor. In most deep caves, the air is saturated with moisture, preventing tissues from drying out quickly and potentially encouraging the formation of adipocere, corpse wax, which preserves the shape of soft tissues. However, if the cave is dry, moisture quickly evaporates, promoting natural mummification. Limited oxygen is also critical. In enclosed spaces, oxygen levels are often low, suppressing the activity of aerobic bacteria responsible for rapid decay. Anaerobic microorganisms take over, working much more slowly. Finally, the specific chemical composition. Calcium-rich waters can gradually coat remains, promoting mineralization or even complete fossilization. Calcite forms a kind of shell, protecting against further destruction. All these conditions turn a cave into an ideal yet eerie natural mausoleum. This will change how you think about what happens to soft tissues after death. In 99% of cases, we expect complete decomposition, but in cave conditions, their fate can be very different, from complete preservation to transformation into unique substances. The fate of soft tissues, skin, muscles, internal organs, after 10,000 years in a cave depends on a very delicate balance of conditions. If the cave is dry enough and well ventilated, the body may undergo natural mummification. Water evaporates from the tissues faster than they decompose, stopping bacterial activity. The skin becomes dry, parchment-like, tightly stretched over the bones, preserving facial features and body contours like an ancient scroll. It's a rare but striking phenomenon. A completely different scenario unfolds in conditions of high humidity and complete lack of oxygen. For example, in underwater cave lakes or clay deposits. Here begins a process known as saponification, or the formation of corpse wax, adipocere. The body's fatty tissues react with water and minerals, turning into a dense, waxy mass resembling soap. This corpse wax can preserve the shape of the body and even internal organs for millennia, creating ghostly but surprisingly durable imprints of the past. These finds allow scientists to glimpse the anatomy and even the lifestyle of long-gone people. When the millennia-hidden cave entrance finally opened, researchers found something astonishing: intact bones and teeth surviving unimaginable time. They are timeless witnesses that can tell us a story when everything else has long disappeared. If the body's soft tissues are fleeting records, bones and teeth are granite scrolls of history. They're remarkably resistant to decay, making them key witnesses to life after 10,000 years in a cave. Bone tissue consists of an organic matrix, collagen, and inorganic minerals, hydroxyapatite. The mineral component provides strength and durability. Over time, the organic part gradually breaks down, but the mineral base can remain almost unchanged. Teeth, thanks to their enamel, are even more resistant, withstanding aggressive environments that would completely dissolve bones. In cave conditions, especially with calcium deposits, bones may even undergo mineralization, further strengthening their structure, turning them into fossils. They don't just retain their shape, they hold invaluable biological information. You can determine the age, sex, diseases, injuries, even the diet of an ancient human. DNA contained in the bone marrow can be extracted and analyzed, revealing the genetic secrets of our ancestors. These timeless witnesses are true time capsules, allowing scientists to reconstruct pictures of life that existed long before us. Imagine, over 10,000 years, billions of microorganisms and slow geological processes not only decompose, but paradoxically preserve the body. Surprisingly, these seemingly destructive forces can transform mortal remains into eternal artifacts. We tend to think of bacteria and fungi as the main mechanisms of decomposition, and that's true. Under normal conditions, they quickly return organic matter to the cycle of nature. But in the unique conditions of a cave, their role can be very different. At low temperatures, and most importantly, with a lack of oxygen, the activity of most destructive microorganisms is drastically reduced. Some anaerobic bacteria continue to work, but much more slowly, and sometimes even contribute to the formation of protective substances, such as the corpse wax we talked about earlier. However, geological processes can become true keepers. Waters saturated with minerals, especially calcium carbonate, seep through cave ceilings. Drop by drop, they can coat the remains, forming a hard crust. This process, known as calcification, gradually turns the body into a part of the cave itself, protecting it from external influences. In rare cases, organic substances can be completely replaced by minerals, leading to fossilization, turning into stone. It's a slow but incredibly effective transformation, capable of preserving even the smallest details for tens of thousands of years, making the body part of the eternal geological record. Imagine the moment when, after 10 millennia, you look into the face of a person from the deep past. It's not science fiction, but a reality that caves give us, preserving amazing evidence of life and death, defying time itself. Incredible stories about bodies surviving millennia in caves aren't fiction. In Spain, in the Sime de los Huesos cave, remains of hominids over 430,000 years old were found, preserved by unique conditions. In the Alps, in a glacial cave, they discovered Ötzi the Iceman, naturally mummified about 5,300 years ago. His body, clothing, and tools provided invaluable information about life in the Bronze Age. These finds aren't just bones, they're entire libraries of information. They allow scientists to study ancient diseases, diet, migrations, and even causes of death, shedding light on our own evolutionary history. Each such find is a window into the past, proving that caves are truly the greatest keepers of time. We hope this dive into the mysteries of millennia has captivated you. If you, like us, are fascinated by the mysteries of the past and the unexplored sides of our world, be sure to subscribe to Mysteries of the Spirit so you don't miss new amazing stories. Hit like if this topic made you think about eternity.